Hi, Professor. This is Sai Sandeep Polsetti. I hope you are doing well. Let me share my screen. I hope you are able to see my screen. Thanks for giving the opportunity to present my final presentation on business intelligence and data analyst agenda. So the agenda of this presentation is how the World or Health Organization would basically help in estimating about the prevalence and the mortality of tuberculosis burden within the world. So these are the contents which I'm going to talk in this video in detail. That is introduction about the data set, that is tuberculosis burden, and what are the display of visualizations that is a world map which shows all the countries and death by age group, the top countries, and death by gender, death by top 10 countries by age group, death over years, and death by age group and gender based on that, and death rate by number of deaths, and death by age group and the gender as well, and the final dashboard of a data set. And dataset or the which concludes the all the final conclusion as well. So when coming to the introduction, so tuberculosis is caused by a bacterium called Mycobacterium tuberculosis. The bacteria usually attack the lungs, but TB bacteria can attack any part of the body, such as kidney, spine, and brain. All the organization with the isolation of test data, which consists of around 200 to 2000 isolations from various mutations that has been profiled. Each data point to have contain the features that are most popular considered as resistance predictors, and these features are also used for the purpose of a prediction that majorly consists of two groups. The first group is all about the mutation, which is considered as a predictor, and its status is binary. And the second group consists of derived categories based on the groups that rare mutations can locus. And each point data to be contain the features and most popular considered as predictors. This is much about the introduction of tuberculosis burden, which I'm going to talk in detail in the next slides. So the data visualizations of which I have taken is in the first display is the world map on the tuberculosis. The World Health Organization would basically help in estimating about the prevalence and the mortality of tuberculosis within each country. The data set consists of training data and consists of nearly 3,393 MTV. The data is about the tuberculosis based on the countries. The map shows the pointer with the country is most affected in all above the countries. And it talks about the China and India has most affected countries as per the map. And there are many other countries which are affected with tuberculosis, like US, Nigeria, Indonesia, Russia, and at least these countries have 10 million deaths occurred. And next visualization is based on death by age group. So these are given by number of deaths in the age group, and most of them are happening at the age of 80 plus, which is nearly 75 million. And whereas in the 70 to 80 years, there is the same kind of rate, which is 40 million. The least occurrence is taking place at the age of 10 to 15 years. And whereas in the coming to 0 to 6 days in the initial period when the children is born, it is showing as 29 million, and whereas from 1 year to 4 years, just 36 million. And as mentioned, it's very less compared to other years. It's 10 to 14 years, which is a 5 million. This is the least one in the table. And whereas it's going on increasing from 30 to 34 gradually to 75 to 79. And whereas from 28 to 364 days, that is less than 1 year, it is quite expensive, and the death rate is very expensive, and it has been nearly 35 million for the very children people. And the next one is based on the top countries. What are the top countries that are more affected? So data is all about the tuberculosis based on the countries. So among all the countries, India has the highest of about 118 uh, 188 million. So the next highest is China, is about 156 million. So there are other countries with less affected countries like Germany, which is about just an 18 million deaths. And whereas Indonesia, it is having 28 million, and Pakistan, it has have of 21 million, whereas Brazil, it is having 19 million. On Bangladesh, it is having the same 21 million, nearly 570,000, and whereas Russia, it is having 74,000. Sorry, 74 million. And the next one, it talks about the death based on the gender. So in the gender, the given chart shows about nearly gender male and female that has 255 million deaths, and the female gender has 218 million. So the minimum number of deaths in both of the genders is nil, that is 0. So at least we have one death in each gender. The color shows details about the sex, what are the genders, and the size shows minimum of number of deaths. And the male has more deaths compared to female. So this is all about the death by gender. The next visualization is about death of top countries by age. Given graph shows about death on the country and age group. In China, ages greater than 50 has most death rate. In the middle of 30 to 49 age, it has the death rate more about 10 million. Whereas less than 10 years, 30 years, India has most deaths about 40 million. And there are some other countries which has affected with the age of 30 to 49. We can see as a Bangladesh is nearly 1 million, and the Brazil has 1 million though, and whereas China and India is exceeding with many other deaths, and other whereas Indonesia, Nigeria, Pakistan, and Russia and United States has very less number in the middle ages, the death rate. Whereas in the greater than 50, China and India stands in the top. The next level goes to the United States, where it's nearly 19 million. And whereas in Russian Federation, it is 13 million. And Pakistan, Nigeria, and Germany, which is greater than 2 million deaths. Whereas in the youth, which is less than 30 years, the India has the most one, which is nearly 39 million deaths, and the next one comes in the China, which is less than 16. It is nearly 16, we can say, and whereas the Nigeria and Indonesia, it is nearly 5 million of death rates for less than 30 years. And the next one is death over the years. When we consider there are many other countries which is starting from the 1970. When we consider the starting, it has 172 million all over the world. It gradually increased by every decade, and when it comes to the 2010, it says every decade it says 210, 567, 809 average. And when we consider with the different years, in 2070, 1970 it has 172 million, and whereas 1980 it has 175 million, and in 1990 it has 185 million. In 2000 it is 204, and by 2010 it is 210 million. So by every decade it has been increasing very gradually. And death by age group and gender in detail. So the graph tell about the death by age and gender format, and the top death rate is at nearly of 80 plus, and female has most of about 22 million. So when we consider the graph by age group and the gender, When it considered about 0 to 6 days, the female death rate is 6 million, and whereas male death rate is 8 million. Whereas from 1 to 4 years, the death rate is nearly female to 8 million, and the male death rate is 9 million. So when we consider from Y to all this 15 to 19 and 20 to 24, the death rates of male are more compared to the female. And whereas from 28 to 364 days, that is less than 1 year, the death rates are very high. Even the male gender stands in the first with 9 million. Whereas from 30 to 34, it gradually increases, and the male stands in the same way with uh, with 11 million at the age of 70 to 75. Whereas 75 to 80, the female death rate is more, and it is nearly about 22 million when compared to male gender. So this is all about death by age group and gender in detail. And the next one is the death rate by number of deaths. The graph shows of each rate by 1,000 deaths, and the number of in the year. The graph is about 115 million. There is a little spike up in 1980, and by 2000, it is gradually increased by to 2010. The death is about 210 millions. When we check the graphs, so in the 1970s, it is nearly 115, and whereas in by 180, it is nearly 95 million. And when we see for 1990, it is 79 million, and in the 2000, it says 68 million, and 2010, it says 55 million, thousand, 100 and 1,000 as per the graph. And when we considered by 2010, it says 210, 567, 819 deaths. So every decade it has been increasing. And the next one is death by age group and gender. The overview shows the death count based on the age group and sex. The less than 30 years, male has about 42 million and female has 33 million. And greater than 50 age, male has 69 million and female has 65 count. The middle age, nearly 30 to 45 years, the death rate is about 10 million in both the genders. So when we consider the graph, in every graph there is a male death is more when compared to the female, and in the less than 30, the male is about 42 million, and in the middle ages the male has a more, that is 15 million, and in the same age of middle age, that is 10 million compared to the male deaths. So this is all about the death by age group and sex. And the next the data set dashboard, which we have done so far. It is based on the 3 graphs. The dashboard contains the map death rate by number of deaths and the top 10 countries for the age group. So India and China are most affected countries in the given map. And in the year 1970, the count is about 115 million, and by 2010, the death is about 210 million. So the China and India are the greatest ones in the maps. The age greater than 50 has more death rate. In the middle of 30 to 49 age, India has most affected country with the 10 millions to in the death rate of about 10 millions in the middle of 30 to 49 age. So these are all about the visualizations that we have covered so far with the different kind of rate tables and the death rates. To conclude on this, the first group is all about the mutation, which is considered as a predictor, and its status is binary and secondary group. So this data sets consists of drugs that are available, And so this problem can also be posed as a multitask classification problem, and we would be trying to develop a single model which can help to simultaneously perform on all the classification tasks. Based on the given data sets, we would also be available to explore the alternative viewpoints, which can help in reducing the burden. There will be a first group which will be considered the mutation of the predictor. The mutation that will gain the binary in the group, this data can be consisted with the drugs which has been available in trying to develop the single type of model. In 2020, 86% of newly TB cases has occurred in 30 high affected burden countries. 8 countries accounted for 2/3 of new TB cases. This all will be based on the data sets which has been given in the available to explore with the alternative kind of points that will be reduced in the burden. The first group is all about the mutation, which is considered as a predictor, and the status is binary. The status consists of drugs that are available and keeping the classification of the problem, and we would be trying in the single model and simultaneously with the classification of the task. So based on the given data, so we would also be available to explore the alternative viewpoints which can help in reducing the burden. And these are all about tuberculosis burden based on all the countries and based on the over the decades that we considered what are the deaths based on the genders, ages, and different kind of rate tables. And these are the references which have differed from WHO and Jacob and Dye. And once again, thanks for giving the opportunities to be a part of the CSP. And I learned many things from the business intelligence and the data analyst course, and it helped me a lot in real life as well. A special thanks and greetings to Heather Wagert. I hope we meet you in the campus soon. All the best to everyone. Thanks.